Going live in right now. Alrighty. All right. I'm David, and we have Jacob and Joseph here, and we're doing Hack the Bay, a hackathon. And we chose challenge one due to our data science backgrounds. Us three are recent graduates of a data analytics course at GW. And I came upon this hackathon through a friend and thought it'd be a good way for us to practice, practice data cleaning, practice our visualization skills, and just practice, what we've learned over the past 6 months at our class. And we thought the subject matter was interesting as well. Those of us who've lived, in and around the Bay and in the DMV know, the history and how polluted it's been. And we were hoping that it's gotten better. And we're very curious about that.
Thanks, David. So getting into our analysis. So our analysis was centered around three major health measures: temperature, pH, and conductivity. We also then needed to select a particular HUC to end up looking at. So we had to use some eligibility criteria to figure out which was going to be the one, as well as filter out some of the others. For that, we decided to look at making sure that these HUCs had data covering each of the health measures we were looking at. So temperature, pH, and conductivity. And then making sure that they had enough consecutive data for us to actually draw conclusions from. For that, we looked at making sure that they had at least 3 years, if not a little bit more, 3 years of data, and then making sure that there were no gaps or minimal gaps in the data collection. For that, we went with about a maximum of 100-day gap in data collection. Any less than that and ended up being a little bit too restrictive. Any more than that, and we couldn't really say that it was that consecutive. Once we had our eligibility criteria set, we then dove into our methods. We prepared the raw data covering temperature, pH, and conductivity, so extracting our measures. We then identified HUCs that met our eligibility criteria. We looked for averages for the different measures by quarter. This allowed us to look at seasonal changes. We then identified the average rate of change over time for each of the measures within the HUCs for each quarter. And then identified HUCs with higher degrees of change over time for our kind of final selection process. This methodology did have some limitations, of course. The first was that we were limited in scope to temperature, pH, and conductivity. Limiting that allowed us to, develop our methodology a little bit. But that is something that could be expanded upon in future projects or next steps. As far as the eligibility criteria goes, this was a bit of a limitation as far as dealing with the consistency of data collection. Out of the original 500 or so HUCs that we had to work with, we ended up only finding about 26 that were suitable according to the eligibility criteria. Then that likely introduced a little bit of bias into our analysis, in that HUCs that had more consistent data collection were likely or could potentially be a little more focused on water health, meaning that those HUCs that had better outcomes were potentially the ones that were the most consistent with their data collection efforts.
And this led us to the South River, and it's, the South River is in Southwest Virginia. It's one of the two tributaries that feed into the southern fork of the Shenandoah. The Shenandoah drains into the Potomac at Harper's Ferry, and then of course, Potomac drains, hundreds of miles south in the Chesapeake Bay. So that links it right there. And the South River is quite interesting. I found out that, due to pollution from I think a DuPont chemical plant from 1929 to 1950, the river, even to this day, almost 100 years later, is polluted with mercury, and they have fish advisories that say no fish besides trout is safe to eat due to high levels of mercury. And because of this, the river has been subject to remediation efforts, and you can see a few of those efforts on the side here. That's from the website, focus on the science behind the South River and just water cleanup efforts there. And it certainly was, a large part of it was because of mercury and try and reduce those levels. But of course, remediation can do all sorts of things, and it was along those lines as well, just to help with the general water quality and having less runoff and more trees on the banks and all that sorts of remediation.
So within the South River, we chose the Canada Run South River Huck. We primarily chose this because of the over 500 initial hucks that we initially started for. This one ended up having the most data points. Now, when we took our refined data and analyzed it, we learned that, however, with all these data points, we saw that within seasons, there is a high degree of variability with the quantities measured. Also, another interesting thing is that in 2014, within the George Washington National Forest that the South River runs through, it was designated to be a priority watershed. Now, our data shows that over a time period of 5 years, Canada Run saw significant improvements in its conductivity and pH scores and a slight decrease in water temperature. The water temperature data is surprising given that it's been trending up overall in the region. Now, these changes in pH and conductivity roughly corresponds with its designation as a high priority watershed. It's unclear at this time, given our data, if the remediation efforts that comes with that designation is what made that difference in those scores. Now, once we've collected our refined data, we then ran it through Tableau to create some data visualizations as well.
So in Tableau, in our first part, we first wanted to see, to get an idea of the hucks we were dealing with. We wanted to see, visualization of high and lowest average temperatures. So we made a little animation here that shows, all around the watershed what the temperatures were, just to get an idea. And then down here we have the ones that the hucks that are eligible, around the 30 odd ones. And so here we can organize it by highest to lowest here. So you want to see for connectivity, the highest score being 610, and then all the way down to here being 37, being very low. Just so we can play around the data to see what measurements were outliers, which were average, and just to try and judge from there. And then here we just made some, as we discussed before, visualizations for our Pacific Huck. And as I mentioned, the temperature is trending up slightly before dropping significantly. And this could have been an outlier because it was 2020, and it was in the winter. And I think that issue is collecting data because of COVID. So right here, this might not be accurate with 6.3. However, it even went down in 2019 by a full degree in Celsius, so it's relatively significant. pH was a huge one here. It started in 2014, 2015, very little change, 4.5, which is really not healthy for a water system. And went up 2018, 2019, and then staying through the 2020, around 7, which is very healthy. So this is good news for this huck and good news for that watershed in general. And for connectivity, good measurement is around 150 to 500, and what's 2014, 2015 again, starting 12, so pretty terrible, and then ending last 3 years 320, 225, 308, 400 in 2020. So good score, good baseline score, and a kind of a score you want to see for a healthy waterway and healthy ecosystem. And then here in the bottom, we broke down the quarters, and just to show the variability in seasons and in months for certain measurements. And some of them are pretty normal, some had some variation, and it totally depends on what the measurement was and what the season was. And yeah, that's our presentation. Here we have a bunch of links here from South River Science team being we have a science website focused on the river and the remediation, and a couple government ones as well. So thank you guys for watching.
Thank you for listening.
Thank you.